Have you ever wondered if you could actually see a sound? Or what it would look like if you could watch music travel through the air? Imagine if every note, every beat left a visible trail, painting the air with invisible waves. Or have you ever stopped to think about why your microwave heats up your leftovers so quickly, yet the plate underneath stays cool to the touch? It almost feels like magic, but it's really science at work, using waves we can't see. All around us, the world is alive with invisible forces, sound, light, and waves, constantly moving, bouncing, and shaping everything we experience. These hidden energies govern how we communicate, how we see, and even how we cook our food. Most of us only catch a glimpse of how these phenomena work, but they're always there, quietly influencing our daily lives in ways we rarely notice. From the light that lets us read at night, to the sounds that fill our homes, these forces are everywhere. It's the same science that lets us send cat videos and messages across the world in an instant, using beams of light traveling through tiny glass fibers. By the end of this video, you'll uncover the secret science behind these everyday wonders. You'll see how the ordinary becomes extraordinary when you know what to look for. We'll dive into how sound can be powerful enough to shatter glass, how special cameras can reveal a hidden world in total darkness, and why mirrors sometimes play tricks on our eyes and change the way we see ourselves. Get ready for 10 fascinating, tell me why facts that will forever change the way you see and hear the invisible world of sound, light, and waves all around you. Let's solve a kitchen mystery that's puzzled almost everyone at some point. Why does your food come out piping hot from the microwave, while the plate underneath often feels barely warm or even cool to the touch? It's a question of science, and the answer lies in the way microwaves interact with different materials, especially water. Microwaves are a type of electromagnetic wave, and your microwave oven is designed to produce waves at a frequency that specifically excites water molecules. When these waves penetrate your food, they cause the water molecules inside to vibrate rapidly. This vibration creates friction, and that friction generates heat from within the food itself, making it hot and steamy. But most plates, especially those made of ceramic or glass, don't contain much water. Their molecular structure doesn't respond to microwaves in the same way food does. Instead of absorbing the microwave energy, these plates allow the waves to pass right through, leaving them mostly unaffected by the heating process. That's why, when you touch the plate after microwaving, it's usually cool, unless it's been in contact with hot food, which can transfer some heat to the plate's surface. So, the next time you're amazed by a hot meal sitting on a cool plate, remember it's all thanks to the unique way microwaves interact with water molecules, and not with the plate itself. It's clever physics at work, not magic. Your microwave is simply targeting the water in your food, leaving your plate mostly untouched. That's why your leftovers heat up quickly, but your plate stays cool. Next time you reheat a meal, you'll know exactly what's happening inside your microwave. You've seen it in movies. An opera singer shatters a glass with her voice. It's not a trick, it's resonance. Every object, like a wine glass, has a natural frequency, the pitch it likes to vibrate at. If a singer matches that frequency, each sound wave adds energy at just the right moment. The vibrations build up, growing stronger with each wave. Eventually, the glass can't handle the stress and shatters. It's not about volume, but about hitting the perfect pitch. Resonance turns a simple vibration into a destructive force. That's the science behind breaking glass with sound. Perfect timing, perfect pitch, physics in action. Don't forget to like, subscribe, and share if you enjoyed learning about sound waves. Stay tuned for more mind-blowing facts. In total darkness, an infrared camera reveals a hidden world that's completely invisible to our eyes. When you walk into a room with no lights on, it might seem like nothing is there, but an infrared camera can instantly show you what's really happening. It's almost like having a superpower, being able to see things that are otherwise hidden in the shadows. These cameras don't see visible light. They detect heat, or infrared radiation, which is a type of energy given off by everything that's warmer than absolute zero. Instead of capturing the colors and brightness we're used to, infrared cameras pick up the invisible waves of heat that objects naturally emit, no matter how dark it is. Our eyes can't see infrared, but thermal cameras use special sensors to pick up even the tiniest temperature differences. These sensors translate heat into images we can understand, creating a colorful map of temperatures. This technology allows us to see things that would otherwise be completely hidden from view. Hotter objects appear bright or white in thermal images, while cooler ones look dark or blue. This contrast makes it easy to spot living creatures, warm machinery, or even recent footprints left on a cold floor. That's why people and animals seem to glow in thermal images, even in pitch black. Their bodies give off heat, which stands out clearly against cooler backgrounds. Infrared cameras don't need any light source at all. They just collect the heat radiating from everything around them. This means they work perfectly in complete darkness, through smoke, or even in foggy conditions. This makes them invaluable for night vision, firefighting, search and rescue, and even for spotting overheating electronics or hidden leaks in buildings. Professionals rely on them to find people in emergencies or to diagnose problems that can't be seen with the naked eye. They literally let us see the invisible world of heat, revealing patterns and details that would otherwise remain hidden. From wildlife tracking to energy efficiency, their uses are almost endless. That's how we see in the dark, by detecting warmth, not light. Thanks to infrared cameras, we can explore and understand a world that's always been there, just beyond the reach of our eyes. This is going to blow your mind. Did you know some mirrors can actually make you look taller, shorter, or even upside down? Mirrors don't always tell the truth. Sometimes they stretch or squish your reflection. Flat mirrors show a true image, but curved mirrors distort. Convex mirrors, curved outwards, make you look smaller and wider by spreading out light rays. That's why car mirrors warn, objects in mirror are closer than they appear. Concave mirrors, curved inward, can magnify or flip your image depending on your distance. Get close, and you look larger. Move back, and you might appear upside down. Funhouse mirrors combine curves for wild effects. It's all about how light bounces off the surface. The shape of the mirror changes how you see yourself. Neon signs aren't always neon. The classic red-orange glow comes from pure neon gas. But what about other colors? That's where different gases come into play. Inside each glass tube, a high voltage excites the gas, turning it into plasma. This plasma state is key to the magic. When electrons in the gas atoms get excited, they jump to higher energy levels. As they return to their original state, they release photons, packets of light. Each type of gas emits a unique color when its electrons drop back down. Neon glows red-orange, argon glows blue, helium gives yellow, and so on. By mixing different gases or using colored glass tubes, we can create an even wider array of hues. The specific color emitted is like the atom's fingerprint, unique to each type of gas. This is how we get a dazzling rainbow of glowing signs lighting up our cities. It's a beautiful blend of chemistry and physics, lighting up the night with vibrant colors. Why does a bass drum sound deep while a triangle rings high? It's all about frequency, the number of vibrations per second. Low-pitched sounds vibrate slowly, high-pitched sounds vibrate quickly. Our ears interpret slow vibrations as low notes, fast ones as high notes. Every instrument produces a mix of frequencies, creating music's rich texture. Each note has a specific frequency, measured in hertz. Music is a symphony of vibrations, from deep bass to soaring violin. That's why every sound has its own pitch. Inside your ear, tiny hair cells in the cochlea are each tuned to specific pitches. Some respond only to deep bass, others to high notes. Humans can hear pitches from about 20 to 20,000 hertz, but as we age, we lose the ability to hear the highest notes. Some pitches can even trigger strong emotions or memories, making music a powerful experience for the mind and heart. The internet's speed owes a lot to fiber optic cables, thin strands of glass that carry data as light. Data is converted into pulses of light and sent through the fiber's core. The secret is total internal reflection. Light bounces down the cable without escaping, thanks to the difference in glass layers. This keeps the signal strong over long distances. Light travels incredibly fast, about 70% the speed of light in a vacuum. At the other end, the light pulses are turned back into electronic data. It's a simple, elegant use of physics powering our digital world. That's how your cat videos travel the globe in milliseconds. Fiber optics, fast, efficient, and revolutionary. Why is the sky blue? It's all about scattering. Sunlight contains all colors, but blue light has a shorter wavelength than red. When sunlight hits tiny air molecules, blue light scatters much more than red. This scattered blue light fills the sky from every direction. Our eyes are more sensitive to blue than violet, so the sky looks blue, not purple. Red light, with its longer wavelength, passes through with less scattering. That's why the sky is blue during the day. It's a beautiful side effect of physics in our atmosphere. The old incandescent bulbs waste up to 90% of their energy as heat, making them highly inefficient. LEDs, or light-emitting diodes, use semiconductors to convert electrical energy directly into light, with minimal heat loss. When electrons cross the semiconductor junction, they drop to a lower energy state and emit photons, producing visible light efficiently, not heat. This process, called electroluminescence, allows LEDs to convert over 80% of input energy into light, compared to just 10% for incandescence. LEDs use a fraction of the electricity, reducing energy bills and carbon footprint. and can last up to 25 times longer than traditional bulbs. With no fragile filaments to burn out in solid-state construction, LEDs are more reliable and resistant to shock and vibration. They're durable, emit less heat, making rooms cooler, and are available in a range of colors and brightness levels. That's why homes and businesses are rapidly switching to LEDs for smarter, safer, and more sustainable lighting. Bright ideas powered by advanced technology and smart physics. Have you ever wondered why the sky glows blue by day, but the sun transforms into a blazing red orb at sunrise and sunset? It's all thanks to a magical trick called scattering. The same reason our sky is blue, but with a dramatic twist as the day begins and ends. When the sun hugs the horizon, its light must journey through a much thicker slice of our atmosphere, like shining a flashlight through a foggy window. The shorter blue and violet waves scatter away, lost in the vastness, before they ever reach your eyes. Only the bold, longer wavelength reds and oranges survive this epic journey, painting the sun in fiery, unforgettable colors. And here's a surprise. The more dust or pollution in the air, the deeper and more dramatic those sunset reds become. Nature's own special effects. Every sunset is a living masterpiece, a reminder of light's incredible journey across the sky. The colors you see are the story of sunlight's adventure, shaped by the path it takes and the world it travels through. Isn't that just a little bit magical? There you have it, 10 mind-blowing facts about the invisible world of sound, light, and waves. From microwaves to sunsets, physics shapes our reality in magical ways. Which fact surprised you most? Let me know in the comments. If you enjoyed this journey, hit subscribe and ring the bell for more. Thanks for watching, and as always, stay curious.